We look at the relationship between differentiation and integration. And basically, what happens is that if you are given a function here, and this function, what happens is when you differentiate, what happens is that you get the first derivative. If you have been given the first derivative and you integrate it, then you get the original function, and this is basically part of the key lesson that we learn in calculus. Given your f of x to be equals to x squared, therefore the first derivative of that will give us 2x. So for us to get the original function, f of x will then be equals to the integral of f prime of x dx. And that is the integral of 2x dx. Of integration, so we'll get to x squared over 2 plus c, which is x squared plus a constant. We want to look at the relationship. For number 2, we want to look at the relationship between tan x times sec x and sec x. So if we integrate tan x times sec x, we get sec x, and if we differentiate sec x, we get tan x sec x. So we can say then df dx will be equals to what? And we expect the answer to be equals to tan x sec x. Remember, your f of x, if I'm differentiating, I can write this as 1 over cos x, and this I'm going to use the quotient law. To 1, my u prime is equals to 0, my v is equals to cos x, and my v prime is equals to negative sine x. And therefore my df over dx is equals u prime times v minus sine x divided by cos of x squared using the quotient rule, which is sine x all over cos squared x. And that gives me tan x sec x. So the integral of tan x sec x dx will give me sec of x plus c. Just a constant of integration. So how do I do that? I'll take this and I'll write it exactly as sine x over cos x times 1 over cos x dx, and that will be the integral of sine x all over cos squared x dx. So I let u is equals to cos x, and I want to use a substitution method. Then I say du my dx is equals to negative sine x, and that means that my dx is equals to minus du all over sine x. And so that means then I can write the equation as sine x over u squared times negative du all over sine x. So what I'm sure about is that these two will cancel out, and that makes it easier for me. With that information, then what I have is a negative u raised to power minus 2 plus 1 divided minus 2 plus 1 du plus c. So, and that gives me 1 over u plus c. And we know what is 1 over u? 1 over u is 1 over cos x plus c, which will give me the sec x plus c. So I've shown that if I have a function f of x is equals to 2x all over x squared plus 1. So what happens to this variable? It is 2x over x squared plus 1. When I integrate, I get and when I differentiate. So this is when you differentiate, and this is when you integrate. So that's what we want to show, that when I differentiate, I get that, and when I integrate, what do I get? So that we can link the relationship. So I'll start off with the differentiation. F of x is ln of x squared plus 1. So the df over dx will be equals to. So how do we differentiate the ln? You take this, you differentiate it, and this gives you 2x. So I'll put 2x there, and then I'm going to divide with the original function. And that is the rule of differentiation. So I've seen that if I differentiate ln of x squared plus 1, I get 2x over x squared plus 1. What about if I do the integral part? So if I integrate 2x over x squared plus 1 dx, so I let u is equals to x squared plus 1, and then du dx is equals to 2x. And what does that give you? And that tells you that my dx is du over 2x. So if I come back to my integral, I'll write it as 2x over u times du all over 2x. Again, we can easily see that that cancels. And if I integrate du over u, the integral, and this gives me ln of u plus c. And that is ln of u. My u is x squared plus 1 plus c. And that shows